Next one is substitution reaction and elimination reaction. Reactivity order of alkyl halides. In that even mechanism, reactivity of even mechanism is primary is less than secondary is less than tertiary. E2 is E2 mechanism reactivity order is primary is less than secondary is less than tertiary. And SN1 mechanism also primary is less than secondary is less than tertiary. In SN2 mechanism reactivity order is tertiary is less than secondary is less than primary. uh, Actually SN2 and E2 are both are nearly same, and E1 and SN1 are also nearly same. SN2 or E2 favored by high concentration of strong nucleophile or strong base. Rate of reaction directly proportional to the substrate, nucleophile and reagent. Rate of reaction directly proportional to the reagent and the nucleophile. SN1 or E1 is favored by low concentration of poor nucleophile or weak base. Means SN1 reaction, formation of carbocation takes place. Rate of reaction is directly proportional to the log reagent only. And polar protic solvents H2O, CH3OH, HCOOH means which one donate the proton, we call it as polar protic solvents. For example, H2O, H plus OH minus, CH plus OH minus, H plus COO minus, we call it as polar protic solvents. And polar aprotic solvents DMSO, CH3CN, C2H5O, C2H5. Next one is Sedgwick rule. In elimination, more substituted or more stable alkene is major product. It is the Sedgwick rule. And reactivity for elimination, tertiary is greater than secondary is greater than primary. Tertiary halides involve elimination, primary halides involve substitution, secondary halides involve both. CH3CHB, Br, CH2CH3 when treated with the alcoholic KOH, it gives 2-butene and 1-butene. And 2-butene is the major product, 1-butene is the minor product. Next, reaction with metals, Wood's reaction. When alkanes are treated with the sodium in the presence of dry ether, it gives alkanes. It is used to prepare higher alkanes. And mixture of two different alkyl halide gives 3 alkanes. If zinc is used instead of sodium, it is called as Franklin reaction. If we treat alkyl halide with zinc in the presence of diether, it is called as Franklin reaction. Next one is formation of Grignard reagent. When alkyl halides are treated with the magnesium in the presence of dry ether, it gives RMGX. Means RMGX is called as Grignard reagent. Carbon and magnesium bond is polar covalent, where magnesium and halogen is ionic. Alkyl halides also react with zinc, lead and mercury. When C2H5Br is treated with zinc in the presence of dry ether, it gives C2H5 twice zinc plus ZnBr2. When C2H5Br is treated with the mercury in the presence of sodium, it gives C2H5 twice mercury plus 2NaBr. When C2H5Cl is treated with the sodium or lead, it gives tetraethyl lead plus 4NaCl. And next one is free radical substitution. Halogenation occurs in presence of light or UV. Follows chain mechanism. When methyl chloride is treated with the chlorine in the presence of UV light, it gives CH3Cl2 plus HCl, and CH2Cl2 treated plus Cl2 gives CHCl3 plus HCl. CHCl3 plus Cl2 gives CCl4 plus HCl. And next one is Ascent favored in polar aprotic solvents. What is the example of polar aprotic solvent? Means DMSO, etc. Which one easily do not donate the proton? S1 is favored in polar protic solvent. Example H2O, CH3OH. Next one, elimination gives more substituted alkene. Sedgwick rule. Wood's reaction used for formation of fire alkanes. Grignard reagent means RMGX. Free radical halogenation requires light or UV. Next one is haloarenes general points. Haloarenes are less reactive than haloalkanes towards nucleophilic substitution because CX bond in aryl halides has partial double bond character due to resonance, and sp2 hybridization bond is stronger. Phenylcation is not stabilized. Backside attack is blocked by pi electron cloud of ring. Hence, nucleophilic substitution occurs only under special conditions. In that nucleophilic substitution reactions, first one is replacement by OH. We call it as Dow process or Dow's process. When aryl halides are treated with the sodium hydroxide followed by acidification, it gives sodium phenoxide, followed by acidification, it gives phenol. Is when chlorobenzene is treated with the NaOH aqueous in the presence of 623 Kelvin and 320 atmospheric pressure, sodium phenoxide is formed. After followed by acidification, Na is replaced by hydrogen, phenol is formed. It is very important reaction. Next one is replacement by NH2. When aryl halides are treated with the excess of NH3 at 573 Kelvin, 60 atmospheric pressure in presence of Cu2O, it gives aniline. That means when chlorobenzene is treated with the ammonia in the presence of 573 Kelvin and 6 atmospheric pressure, it gives aniline and cuprous chloride and water. Next one is reactivity order. It is nucleophilic substitution reaction. We have to check reactivity order. First one is more reactive than the second one is, and the third one and fourth one, because electron withdrawing group at ortho and para position increases the reactivity. Electron withdrawing group means easily grab the electrons and increases the electron density in ortho and para position. Hence reactivity also increases. And NO2 is the electron withdrawing group. So actually first one and second one both are same. In that first one is greater than third one is greater than fourth one. Next one is electrophilic substitution reaction. Halogens are ortho and para degrading but deactivating. Reaction occurs slowly and require a drastic condition. First one is chlorination. Chlorobenzene is treated with the chlorine in the presence of anhydrous AlCl3. It gives two products, one is major and another is minor. 1,4 dichlorobenzene is major one, and 1,2 dichlorobenzene is ortho minor one. At para position is means that is major, ortho means minor. Next one is nitration. When chlorobenzene is treated with the concentrated nitric acid in the presence of concentrated sulfuric acid, it gives 1 chloro 2 nitrobenzene as minor product and 1 chloro 4 nitrobenzene as major product. That is when chlorobenzene is treated with HNO3, one H is replaced by NO2. And next one, aryl halides are less reactive than alkyl halides. Nucleophilic substitution occurs only under special conditions. Dose process, steam and NH3. Halogens are ortho and para directing but deactivating. Group reactivity increases with the strong electron withdrawing group like NO2 at ortho and para position. Substitution, nitration and chlorination are the important reactions. Next one is Friedel-Crafts alkylation. When chlorobenzene is treated with the alkyl halide in the presence of anhydrous AlCl3, in chlorobenzene one H is replaced by alkyl group. At ortho position means we call it minor, and it is major means if one hydrogen is replaced by para position means we call it as major. It is not ortho position, it is para position major. Example, when chlorobenzene is treated with the CH3Cl in the presence of anhydrous AlCl3, it gives ortho and para chlorotoluene. Ortho minor, para major one. Next one is the Friedel-Crafts acylation. When chlorobenzene is treated with the acetyl group in the presence of anhydrous AlCl3, it gives 2-chloroacetophenone as minor and 4-chloroacetophenone as major. Example, when chlorobenzene is treated with the CH3COCl acetyl chloride in the presence of AlCl3, it gives 2-chloroacetophenone is minor and 4-chloroacetophenone is major. Next one is reaction with metals. In that fatigue reaction, when aryl halides are treated with the or heating with the sodium in presence of dry ether, it gives biphenyl. Example, when chlorobenzene is treated with the sodium chloride in the presence of dry ether, it gives biphenyl and 2NaCl. It is important reaction and Woods fatigue reaction also. When aryl halides are heated with the alkyl halides, undergo Woods fatigue reaction and form alkyl benzene as major product. For example, when chlorobenzene is treated with the 2Na and chloropropane in the presence of dry ether, it gives one hydrogen is replaced by the propane group and NaCl. Next one is action of magnesium. When chlorobenzene is treated with the magnesium in the presence of dry ether, it gives phenyl magnesium chloride. It is nothing but Grignard reagent. And next one is reaction with chloral. Chlorobenzene on reacting with chloral produce DDT. DDT, it is a insecticide, para dichlorobiphenyl trichloroethane. When CCl3 CHO is treated with the chloral in the presence of H2SO4, it gives DDT, dichlorobiphenyl trichloroethane. Next one is polyhalogen compounds. In that chloroform, oxidation. Chloroform undergoes oxidation in open air and sunlight and form poisonous phosgene or carbonyl chloride. When CHCl3 is oxidized in the presence of air and light, it gives phosgene plus HCl. Phosgene is a carbonyl chloride. CHCl3 is stored in dark brown colored gas bottles glass bottles to prevent oxidation of CHCl3 into COCl2, and 1% of ethanol is also added to chloroform. Means when chloroform is undergo oxidation in open air, it gives phosgene. Phosgene is a poisonous, and HCl. And the CHCl3 is stored in dark brown colored glass bottles to prevent oxidation of CHCl3 into COCl2. And 1% of ethanol is also added to chloroform. Next one is hydrolysis. Chloroform on hydrolysis produce formic acid. Example, CHCl3 plus 3KOH gives formic acid. HCOOH is called as formic acid plus 3KCl. And carbyl amine reaction or isocyanate test. When chloroform on heating with primary amine and alcoholic KOH produce alkyl isocyanate. This test is used to detect haloforms and primary amines. Example, RNH2 treated with the chloroform in the presence of KOH, it gives RNC. And next one is Riemer-Tiemann reaction. And HCl3 is treated with the KOH, it gives CCl2 plus KCl and H2O. A carbon chloride is the intermediate or a electrophile. When C6H5OH is treated with the carbon chloride, it gives C6H4OH and CHCl2. When it is subjected to KOH or KCl, it gives C6H4OH and CHO. Next one is iodoform. Chemical properties similar to chloroform, but CHI3 give yellow PPT of AgI with AgNO3, but CHCl3 does not give AgCl. Reason: CHI3 is less stable than CHCl3. Iodoform easily give but CHCl3 does not give chlorine. Iodoform positive haloform reaction. Ethyl alcohol secondary alcohols having OH group on second carbon, acetaldehyde and methyl ketones on heating with NaOH and KOH and sodium carbonate or sodium bicarbonate and iodine produce yellow PPT of iodoform. Compounds show positive haloform test are when CH3 CH2OH means ethanol is CH3CH2OH in CH3CH OH these all are give positive test. Alcohols give positive test and aldehydes also give positive test and ketones also give positive test for iodoform. And compounds which does not show haloform test are negative haloform reaction. If any compound has lone pair electron, this reaction due to resonance, these give negative haloform reaction. If any compound possesses lone pair of electron or negative charge, this does not involve in haloform reaction. Next one is carbon tetrachloride. Chemical properties. It is less reactive, non-flammable, used as a solvent. And in nature, CCl4 is a tetrahedral and non-polar. It does not hydrolyze, does not conduct electricity, non-polar in nature, used as a dry cleaning solvent. Oxidation means CCl4 plus H2O in the presence of 500 degrees Celsius, it gives COCl2 means acetyl group and HCl. Reduction means CCl4 in treated with hydrogen in the presence of iron and water, it gives CHCl3 means chloroform and HCl. And alkaline hydrolysis When Cl2 treated with the KOH minus 2 KCl, it gives Cl2C double bond O, and 2 KOH minus 2 KCl, it gives OH twice CO. Next one is compounds which does not undergo negative haloform reaction, means methanol, primary alcohol, aldehyde other than acetaldehyde, ketones other than methyl ketones, carboxylic acid and their salts. Compounds are not having COCH3 group.